October 1942, Guadalcanal. Every night, Japanese barges move supplies down the slot, troops, ammunition, fuel, reinforcing their positions on the island. American PT boats intercept them, and almost every night they fail. The problem isn't bravery, it isn't training, it's mathematics. American torpedoes are set to run at a minimum depth of 10 feet. Japanese landing barges draw barely 5. The torpedoes pass underneath. The twin .50 caliber machine guns mounted on the PT boats fire hundreds of rounds per minute. But against steel-plated barges, the rounds spark and ricochet. By mid-October, Motor Torpedo Boat Squadron 3 has already lost 6 boats. 17 sailors are dead. PT boats were designed to attack destroyers, fast approach, torpedo launch, withdrawal under cover of darkness. But destroyers are no longer the primary target. Now it's 49-foot barges carrying 60 troops at a time. Small, shallow, armored just enough. Lieutenant Robert Lynch has seen the pattern repeat enough times to understand something simple. If PT boats cannot stop the barges, the Japanese will continue reinforcing Guadalcanal, and if that continues, Henderson Field will fall. One morning, walking past the wreckage scattered around the airstrip, he notices something most men have ignored: dozens of destroyed P-39 Airacobras. Engines ruined, wings torn apart, but inside the nose of each aircraft, a 37mm automatic cannon, designed to destroy light armor in the air. And suddenly, the problem no longer looks mathematical. It looks mechanical. By October 1942, the U.S. Navy faced a growing problem in the Solomon Islands. Japanese destroyers had already been forced to reduce their high-speed supply runs to Guadalcanal. Aircraft operating from Henderson Field made those missions increasingly dangerous. So the Japanese adapted. They shifted to smaller vessels, Type A Daihatsu landing craft. Each was 49 feet long, powered by a single diesel engine, and protected by steel plate along the hull. They could carry 60 troops or up to 8 tons of cargo. They were slow, but they were difficult to detect. And more importantly, they rode low in the water, barely 5 feet of draft. American Mark 8 torpedoes had a minimum running depth of around 10 feet, which meant that any torpedo launched at a Daihatsu barge would pass directly underneath it. Even a perfectly executed attack would result in a miss. Machine guns offered little improvement. PT boats carried twin .50 caliber Browning machine guns, effective against wooden craft, capable of sustained fire. But the barges were not wooden. The rounds struck steel plate and ricocheted. The PT boats could disrupt the convoy. They could force evasive maneuvers, but they could not reliably destroy the barges. And destruction was the objective. Guadalcanal was not simply a series of engagements at sea. It was a contest of logistics. Whoever maintained supply lines would hold the island. Every barge that slipped through delivered reinforcements to Japanese positions surrounding Henderson Field. Every barge destroyed weakened that effort. The numbers made the imbalance clear. 20 to 30 barges could move down the slot in a single night. Even if PT boats managed to destroy 2 or 3, the majority still reached their destination. Incremental damage was not enough. The boats needed something heavier mounted forward. Some crews experimented. They mounted single-shot Army 37mm anti-tank guns on their bows, removing the wheels and bolting the carriage to timber planks. It worked in theory. The gun could penetrate armor, but it required manual reloading after every shot. In a night engagement under return fire, a single round followed by a pause was rarely decisive. What the PT boats required was sustained firepower, automatic, capable of penetrating steel, and light enough to sit on a wooden deck without tearing it apart. It was a narrow set of constraints, And that is when Lynch began walking the perimeter of Henderson Field with a different question in mind. Henderson Field, in October 1942, did not resemble a functioning airbase. It resembled a scrapyard. Coral dust settled over twisted metal. Bomb craters marked the edges of the runway. Damaged aircraft remained where they had come to rest. Some had burned where they crashed. Some had broken apart on landing. Others had simply failed under strain and were left behind. Among the wreckage were dozens of Bell P-39 Airacobras. The P-39 was not the most admired fighter in the Pacific. It struggled at high altitude and proved temperamental in tropical conditions. But at low level, it carried something unusual. Unlike most fighters of its time, the P-39 did not mount its engine in the nose. The engine sat behind the pilot. A long drive shaft ran beneath the cockpit to the propeller at the front. That configuration created space in the nose section, and in that space sat a 37mm cannon. The Oldsmobile M4. It fired through the propeller hub. It was not a machine gun. It was not auxiliary armament. It was a cannon designed to destroy aircraft and penetrate light armor. Many of the P-39s scattered around Henderson Field were beyond repair. Wings were twisted. Landing gear collapsed. Fuselages cracked beyond salvage. Yet in many cases, the cannon assemblies remained intact. They had not been removed. They were considered aircraft components, not naval weapons. Lynch walked past one wreck with its nose buried into coral. The propeller blades were bent backward. The canopy was shattered, but the cannon barrel still extended cleanly from the hub. He understood what that implied. The PT boats did not need another torpedo solution. They needed a weapon that could strike above the waterline, something capable of sustained fire, something powerful enough to defeat steel plate at close range. The M4 met those requirements. The issue was not whether the cannon functioned. The issue was whether it could operate on a wooden patrol boat traveling at speed. There were no drawings for such a conversion. No authorization from the Bureau of Ordnance, no established procedure, only wrecked aircraft, and a squadron that could not afford to keep failing. That afternoon, Lynch approached his commanding officer. He did not submit a formal request. He proposed a practical question. What if we remove one? The next step was not dramatic, it was practical. If the idea was going to work, the cannon first had to be removed from the aircraft, and that was not a simple task. The M4 was not loosely attached inside the nose of a P-39. It was integrated into the aircraft's structure. It was mounted to the engine's reduction gear housing, connected to a hydraulic recoil system, and linked to both a feed mechanism and an electrical firing solenoid. Removing it required more than detaching a weapon. It required partially dismantling a crashed fighter. Lynch and a small group of mechanics moved across Henderson Field with toolkits and cutting torches. They did not touch operational aircraft. They selected wrecks already beyond recovery. The first removal was slow. Hydraulic lines had to be disconnected carefully. Electrical wiring cut. Mounting bolts loosened or burned free where corrosion had seized them in place. The complete cannon assembly weighed over 200 pounds without ammunition. It was not designed to be handled by a small boat crew standing on coral. When it finally came free, it did not resemble naval artillery. It looked like what it was, an aircraft component, grease-stained, scored from prior use, still carrying traces of aviation fuel and coral dust, but mechanically, it remained serviceable. The recoil system cycled properly. The feed mechanism moved without binding. The barrel rifling was intact. That was sufficient. By the end of the day, more than one cannon had been removed from wrecked Airacobras. There was no formal authorization, no engineering review. Just crews working against the fading light, taking equipment rendered useless by air combat and giving it a different purpose. The larger challenge came next. Removing the cannon from an aircraft was one problem. Mounting it on a wooden patrol boat was another entirely. PT boats were designed for speed. They planed across the water at high velocity, their hulls flexing as they struck waves. Their decks consisted of plywood over oak framing, strong enough for machine gun turrets, but never intended to absorb sustained recoil from an automatic cannon firing explosive rounds. The hydraulic system would reduce the shock, but not eliminate it. If the mount failed in combat, the consequences would not be limited to structural damage. The gunner would be exposed directly behind the weapon. There were no naval blueprints for this configuration, no precedent, which meant the next solution, like the first, would have to be improvised. The cannon now existed outside the aircraft. What it required next was a foundation. PT boats had been built for speed, not artillery. An 80-foot Elco boat used a wooden hull constructed from layered mahogany planking. Its deck consisted of plywood laid over oak frames. That structure was sufficient for machine gun turrets. It had never been engineered for sustained automatic cannon fire. The central concern was recoil. The M4's hydraulic system absorbed much of the rearward force generated by each shot, but it did not eliminate it. Every round would transfer energy into the mount. Every short burst would stress the deck framing beneath it. At high speed, sometimes approaching 40 knots, a PT boat flexed as it crossed open water. Any pedestal mount would need to withstand both recoil and constant structural movement. There was no factory solution available, so one had to be fabricated. In Henderson Field's small machine shop, sailors and machinists began assembling a pedestal from whatever steel could be salvaged. Damaged landing gear sections, discarded brackets, fragments of aircraft structure. The design was straightforward because complexity was not an option. A circular base plate to distribute weight, a vertical steel pipe section to provide height, a rotating collar to allow traverse, a yoke cradle to secure the cannon body. There was no precision machining, no formal engineering drawings, only careful alignment, enough to permit rotation and elevation, and sufficient reinforcement to spread recoil forces across multiple deck frames. When the mount was completed, it appeared crude. Weld seams remained visible. Edges were scorched. Bare metal showed where paint had burned away, but the collar rotated, and the structure supported the weight of the cannon. At the dock, the crew of PT-48 marked the forward deck for installation. Holes were drilled through plywood and into the oak framing below. Bolts passed through reinforced structural members. The base plate was tightened down. The cannon was lifted into position. It sat forward of the chart house, centered along the bow. There was no armor plating, no protective shield. The gunner would stand directly behind the weapon, fully exposed. Ammunition introduced another constraint. The M4 used horseshoe-shaped magazines holding 30 rounds. In aircraft service, those magazines were changed between sorties. On a PT boat, they would have to be swapped during combat. The crew stacked loaded magazines on the deck beside the mount. Manual reloads, no belt feed, no additional automation beyond the weapon's own mechanism. The installation was not elegant, but it was functional. There had been no live fire test, no formal stress evaluation, no inspection from higher authority. The only remaining question was whether the mount would hold under combat conditions, or whether the first sustained burst would rip it from the deck. The cannon was installed. There was no ceremony, no formal acknowledgement, only another patrol order. That night, PT-48 moved out with the rest of the squadron. Engines were reduced to limit wake. Lights remained dark. Conversation was minimal. The 37mm cannon pointed forward into open water. No one aboard had fired it from a boat before. The crew had received only basic instruction from airfield armorers. Charge the weapon. Ensure the magazine is seated. Fire in controlled bursts. That was the extent of preparation. Shortly before midnight, radar detected surface contacts. Multiple returns, low speed, barges. The boats adjusted course. On most patrols, this was the moment when torpedo calculations began. Distance, bearing, lead angle. But this time, the objective was different. Lynch needed to close the range, not for a torpedo run, for direct fire. PT-48 advanced inside 1,000 yards, then closer. At that distance, the Japanese gunners could see the approaching silhouette. Machine gun fire began striking the water ahead of the bow. Tracers crossed the darkness. The gunner charged the 37 millimeter. A round chambered. He waited for the bow to steady between wave crests. Then he pressed the trigger. The report was deeper than the crew expected. Not the rapid chatter of a .50 caliber. A single concussive discharge. The flash illuminated the foredeck. The mount absorbed the recoil. The deck flexed, but held. The cannon continued cycling. Explosive rounds struck the lead barge. The difference was immediate. No sparks, no ricochets. Detonations along the hull. Fragments scattered across the deck. The barge slowed. Men moved hurriedly across its surface. Some entered the water. The magazine emptied. The gunner removed it and seated another. 8 seconds. Long enough to feel exposed. Then the firing resumed. A second barge attempted to turn away. PT-48 adjusted course and closed further. The next burst walked along the hull line. An internal explosion followed. Flame spread across the deck. Within minutes, the engagement had concluded. One barge burning, another disabled. The remaining vessels withdrawing into darkness. PT-48 broke contact and pulled away. The cannon had not jammed. The mount had not failed. The deck remained intact. For the first time, PT boats possessed a weapon capable of reliably destroying shallow draft targets. The tactical balance had shifted, not through formal redesign, not through procurement channels, but through adaptation. Within days, other crews requested similar installations. Salvage operations expanded. What began as improvisation became practice. And before official approval arrived from Washington, the aircraft cannon mounted on PT boats had already begun altering operations in the Solomons. The Japanese crews would give the boats a name, Devil Boats, not because of their torpedoes, but because of what now stood on their bows.